We're starting a new chapter today on rational expressions, the graphs of rational functions. Today it's a pretty foundational lesson, pretty much an Algebra 1 review. As you can see, we're going to be multiplying and dividing, and I would say we will include simplifying rational expressions. So when you see the word rational in a math context, you should be thinking fraction. And so that's going to be the focus of today's lesson. The big takeaway from today's lesson is your ability to factor is going to be huge in being able to simplify, multiply, divide. You should always be thinking factor first. Factor as much as you can. And just as a follow-up to that, remember that factoring always involves looking for a GCF first. Okay, so I want you to think factor everything you can, and when you're thinking about factoring, ask yourself, is there a GCF? And if so, that should be thought number one when it comes to factoring. Alright, so this problem 1a, really there's a two-part answer here. Let's take this first sentence and simplify this expression. The numerator is already factored. The denominator can be factored, so let's show that as two binomials multiplied together. And we're going to do the factors of negative 12 that add up to positive 1, positive 4, negative 3. Okay, and the great thing about getting this in factored form is we can now cancel factors. So the rule of thumb is, I know I've said this before, you can always cancel factors, but you cannot cancel terms. Let me show you what I mean by canceling terms. Some people might be tempted in my original problem to cancel like this. Okay, well the problem with that is this x in the numerator is a factor, but this x in the denominator is a term. Okay, a term is always separated by plus and minus signs. So this is a 3-term, we call it a trinomial. Nomial just means term. Tri, of course, is 3. So you cannot cancel individual factor or individual terms from a binomial or trinomial, but you can cancel factors. So let me put this back. And now that we've got all of these in factored form, we can cancel those factors x minus 3. And whatever doesn't cancel, you just write down as your answer, and you do not have to do the multiplication. You would not have to do the distributive property here in the numerator. Alright, so that is my answer to the first sentence, simplify the expression. Now we're going to answer the question, under what conditions is this expression undefined? Well, a fraction is undefined when its denominator is 0. So basically you're asking yourself, based on this expression, and it's what it's referring to, this expression meaning your answer, what would cause this to be undefined? What number could we put in for x to cause this denominator to become 0? Pretty obvious that hopefully you're saying to yourself, well, that would be negative 4. So the condition under which this would be undefined, since it's negative 4, we're going to say that x cannot be negative 4. We got to prevent x from being negative 4, or else we will have an undefined expression. So that's the kind of thing you're going to do on 14 through 18 even. Alright, so letter B, again, you're always thinking factoring as much as you can, and that involves looking for a GCF first. Don't always have one, but you should always make that your first thought. In the numerator, I have these situations called the difference between two squares. And the way I factor this is the square roots in two different groups. One group will be plus, one group will be minus. The same situation applies here. This is the difference between two squares, x plus z, x minus z. The denominator is already factored. And now it's just a matter of looking for matching factors between the numerator and the denominator that can cancel, like x minus 3, like x plus z. And now everything that's not marked out will represent our answer. X plus 3, x minus z, all over 4. Now to answer to the question, under what conditions would this be undefined? Well, there's never a case where this particular answer will be undefined because 4 is a constant. It remains 4. There is no variable down here that can change the value of 4. And since 4 can never be 0, then there isn't an occasion that would cause this to be undefined. Alright, so that ends up being my answer for problem B. Problem C, once again, look for opportunities to factor. There aren't any factoring opportunities in the numerator unless you want to consider this. I typically don't factor monomials, but you would certainly be okay if you wanted to turn x squared into x times x. That's no problem. That's probably a good idea for some. In the denominator, this trinomial, quadratic trinomial, can be factored. There are factors of negative 20 that add up to positive 1, and that's positive 5 and negative 4. Okay, now look to cancel matching factors like x minus 4, like x, and now you just write everything that is not marked out. X times x plus 2 divided by 6 times x plus 5. And now we need to state the condition under which this would be an undefined expression, and that's when the denominator is 0. So to prevent that, we're going to say x cannot be negative 5. Okay, that's all I have for the first part of your lesson or assignment. And now the second block of problems looks like this. 20 and 22 even are very similar. You just don't have to worry about that follow-up question. You don't have to state the conditions under which the expression would be undefined. So once again, we're thinking factoring, and within that thought we're thinking GCF. Well, it just so happens that letter A does have a GCF in the numerator. It's x squared, and when you factor out x squared, you're left with x minus 9. The denominator can be factored as two linear binomials, factors of negative 54 that add up to negative 3 would be negative 9 and positive 6. And now we look for opportunities to cancel matching factors like x minus 9. And so my final answer here is x squared over x plus 6. For problem B, once again, we need to factor as much as we can. So let's factor this numerator as the difference between two squares, 4 plus c, 4 minus c. The denominator will factor as two linear binomials, remembering the factors of negative 20 that add up to positive 1, c plus 5, c minus 4. Okay, so we're left with kind of an interesting situation here. With addition is commutative. Obviously I can turn this around and make it become c plus 4. Trying to make these pretty much look the same. I can't just turn subtraction around. Subtraction is not commutative, so doing this is not an equivalent expression. Notice the c is negative, but now I've made it positive. So here's how I can turn it around and make it equivalent. You can think about factoring out a negative 1. Okay, so now do you see how if you distribute negative 1 to both of these, negative 1 times c is negative c, and negative 1 times negative 4 is positive 4. So this is an equivalent expression. In essence, I factored out -1. You'll never factor out +1, but there are some cases like this where you would factor out -1. So I'm just going to put my negative here at the beginning. I could put -1, but I'll just show it as minus. We already got the c plus 4 and then c minus 4. Okay, and then the denominator really hasn't changed. Okay, so now you can see that we have these factors c minus 4 that can be canceled. And since we have a negative numerator with a positive denominator, that makes the whole fraction become negative. So I'm just going to show my answer as this. C plus 4 divided by C plus 5, and negative for the entire fraction. Negative divided by positive is negative. Okay, and so that is your answer for this Roman numeral 2b problem. Okay, so let's move on to some multiplication, and we'll take a look at a few of these examples. All right, this time we're dealing with monomials, and I'm going to show you my preferred way of doing problems like this, and then I'll let you decide if you want to approach it a little different way. There's probably 2 or 3 different ways. I'm going to do what I can to simplify the coefficients. That means the numbers in front of the variables. And if you recall from your past experience, you can look diagonally and you can cancel, which really is another word for divide. I'm going to divide both of these numbers, 3 and 18, by the same number, which of course would be 3. 3 divided into itself is 1, and 3 into 18 is 6. I can go this way diagonally, and I can reduce or divide by the same number, which would be 4, the largest number that goes into both 8 and 12. 4 goes into 8 2 times, and 4 goes into 12 3 times. And then within a fraction, we've already experienced this a lot. I can take 3 over 6, divide by 3 into each, and make it 1 over 2. Now for the variables, because just simply, really it's more practical than anything, I'm not going to do anything as far as canceling, because for me that ends up being a big mess that's hard to read. So I'm going to go ahead and multiply the coefficients together. 1 times 1 is 1. And now I'm going to apply the property that says if you're multiplying with like bases, you add the exponents for those bases together. So a times a is a to the second. There isn't anything to multiply b with, so that's just going to be b squared. C to the third times c to the first is c to the fourth. And there is no other f variable to multiply, so I'm going to say f to the third. Now I'll do the same thing on the bottom. 2 times 2 is 4. A squared times a is a cubed. B times b to the third is b to the fourth. C times c squared is c cubed. And f to the fourth times f is f to the fifth. And now I'm going to take care of simplifying these variables using the property that says division of like bases means you subtract the exponents. And so this will represent my final answer. I've got a 1 here in the numerator over 4. So if nothing else shows up, if all my variables essentially are removed from the numerator, I'll go ahead and put 1, but we'll see how that goes. Let me see if this makes sense to you. A squared divided by a cubed means a to the first in the denominator. My board's going crazy. Okay. B to the second divided by b to the fourth makes b to the second in the denominator. Notice how 4 is bigger than 2. Now it kind of switches. C to the fourth divided by c to the third makes c to the first, which is just c in the numerator. And putting these two together will make f squared in the denominator. 5 is bigger than 3. And so there is my answer for Roman numeral 3a. Okay, let's try another one. This time we're going to incorporate division, and if you recall back in elementary school you learned that dividing by a fraction means to invert the fraction, which is another word for write the reciprocal or flip it over, and then change this to multiplication. Okay, so nothing changes for this left fraction. But division is going to become multiplication, and this fraction then is going to be flipped over. And now I'm back to the same type of problem I had before. I'm going to just cancel, divide, if I can, into the coefficients. Well, 35 goes into itself one time, into 72 times. Let's see, I can divide each of these numbers by 4. 4 goes into 12 3 times, and 4 goes into 64 16 times. And it looks like that's the only thing I can do as far as reducing the coefficients. So now I'm going to work on just multiplying these together, and then I'll simplify the variables in the end. Okay, so multiplying coefficients together, 16 times 2 is 32. This is going to become a to the third, b to the sixth, c, f squared. The denominator is going to be 1 times 3, which is 3, a to the fourth, b to the fifth, c to the fourth, f to the fourth. And now let's put these like variables together using that division property of exponents. Still going to be 32 in the numerator. The a variable is just going to become a to the first in the denominator. The b variable is going to be b to the first in the numerator. For c, we're going to have c to the third in the denominator. And for f, we'll have f squared in the denominator. And so that ends up being our final answer for letter B. Oh, I just realized I didn't bring my 3 down from up here, so this is your final answer. 32b over 3ac cubed f squared. All right, let's try letter C. Another multiplication problem. So once again, factor everything you can, starting with this left numerator. That would be y plus 5 times y plus 3. The denominator is prime, can't be factored. This right numerator factors as y minus 6 times y minus 3. And the denominator is the difference between two squares, so y plus 3 times y minus 3. And now we start canceling everything we can. Cancel factors, matching factors, the y minus 3's. Going diagonally, you can cancel y plus 3. Diagonally again, you can cancel y minus 6. So all that's left is y plus 5. Okay, I think this is our last one. This is a complex fraction, but it's really a division problem. Dividing by a fraction, again, we talked about this earlier, means to multiply by the inverse of this fraction. So I'm just going to change, I'm going to put multiplication here, and then I'm just going to flip this fraction over, and then we'll be ready to multiply just like we did on the previous problem. So really, I've already taken care of division by the fraction. Don't really need this. Just going to mark it out. And now let's start factoring again. This will be x plus 3, x minus 3. The denominator contains a GCF, which is 6 times x minus 2. This factors as x minus 2, x plus 1. and this factors as x plus 7 times x plus 3. And now we start canceling matching factors like x minus 2, x plus 3, nothing else cancels, and so just write down the factors that remain. You do not have to multiply these together. You can just leave your answer in factored form. And that should be your answer for letter D. And that takes care of all of my examples. Hopefully this will help you with your homework assignment. And work hard on these problems. And if I can help you, let me know.